GPT-3, similar to GPT-2, actually, have captivated some part of the imagination of the public. There's just a bunch of hype of different kind. I would say it's emergent. It's not artificially manufactured. It's just like people just get excited for some strange reason. In the case of GPT-3, which is funny, that there's, I believe, a couple of months delay from release to hype. Maybe I'm not historically correct on that, but it feels like there was a little bit of a lack of hype, and then there's a phase shift into hype. But nevertheless, there's a bunch of cool applications that seem to captivate the imagination of the public about what this language model that's trained in an unsupervised way without any fine tuning is able to achieve. So what do you make of that? What are your thoughts about GPT-3?
Yeah, so I think what's interesting about GPT-3 is the idea that it may be able to learn new tasks after just being shown a few examples. So I think if it's actually capable of doing that, that's novel and that's very interesting, and that's something we should investigate. That said, I must say I'm not entirely convinced that we have shown it's capable of doing that. It's very likely, given the amount of data that the model is trained on, that what it's actually doing is pattern matching a new task you give it with a task that it's been exposed to in its training data. It's just recognizing the task instead of just developing a model of the task, right?
But there's, sorry to interrupt, there's a parallels to what you said before, which is it's possible to see GPT-3 as like the prompts it's given as a kind of SQL query into this thing that it's learned, similar to what you said before, which is language is used to query the memory.
Yes.
So is it possible that neural network is a giant memorization thing, but then if it gets sufficiently giant, it'll memorize sufficiently large amounts of things of the world where intelligence becomes a querying machine?
Mm-hmm. I think it's possible that a significant chunk of intelligence is this giant associative memory. I definitely don't believe that intelligence is just a giant associative memory, but it may well be a big component.
So do you think GPT-3, 4, 5, GPT-10 will eventually, like, what do you think, where's the ceiling? Do you think you'll be able to reason? No, that's a bad question. Like, what is the ceiling is the better question.
How well is it going to scale? How good is GPT-N going to be?
Yeah.
So I believe GPT-N is going to improve on the strength of GPT-2 and 3, which is it will be able to generate, ever more plausible text in context.
So it's monotonically increasing performance.
Yes, if you train a bigger model on more data, then your text will be increasingly more context aware and increasingly more plausible. In the same way that GPT-3 it is much better at generating plausible text compared to GPT-2. But that said, I don't think just scaling up the model to more transformer layers and more training data is going to address the flaws of GPT-3, which is that it can generate plausible text, but that text is not constrained by anything else other than plausibility. So in particular, it's not constrained by factualness or even consistency, which is why it's very easy to get GPT-3 to generate statements that are factually untrue or to generate statements that are even self-contradictory, right? Because its only goal is plausibility, and it has no other constraints. It's not constrained to be self-consistent, for instance, right? And so for this reason, one thing that I thought was very interesting with GPT-3 is that you can predetermine the answer it will give you by asking the question in a specific way, because it's very responsive to the way you ask the question, since it has no understanding of the content of the question.
Right.
And if you ask the same question in two different ways that are basically adversarially engineered to produce certain answer, you will get two different answers, two contradictory answers.
It's very susceptible to adversarial attacks, essentially.
Potentially, yes. So in general, the problem with these models, these generative models, is that they're very good at generating plausible text, but that's just not enough, right? You need, I think one avenue that would be very interesting to make progress is to make it possible to write programs over the latent space that these models operate on, so that you would rely on these self-supervised models to generate a sort of like pool of knowledge and concepts and common sense. And then you would be able to write explicit reasoning programs over it. Because the current problem with GPT-3 is that it can be quite difficult to get it to do what you want to do. If you want to turn GPT-3 into products, you need to put constraints on it. You need to force it to obey certain rules. So you need a way to program it explicitly.
Yeah, so if you look at its ability to do program synthesis, it generates, like you said, something that's plausible.
Yeah, so if you try to make it generate programs, it will perform well for any program that it has seen it in its training data. But because program space is not interpolative, right? It's not going to be able to generalize to problems it hasn't seen before.
Now, that's currently, do you think, sort of an absurd, but I think useful, I guess, intuition builder is, the GPT-3 has 175 billion parameters. Human brain has about 1,000 times that or more in terms of number of synapses. Do you think, obviously, very different kinds of things, but there is some degree of similarity. Do you think, what do you think GPT will look like when it has 100 trillion parameters? You think our conversation might be in nature different? Like, because you've criticized GPT-3 very effectively now. Do you think?
No, I don't think so. So to begin with, the bottleneck with scaling up GPT models, generative pre-trained transformer models, is not going to be the size of the model or how long it takes to train it. The bottleneck is going to be the training data, because OpenAI is already training GPT-3 on a crawl of basically the entire web, right? And that's a lot of data. So you could imagine training on more data than that, like Google could train on more data than that, but it would still be only incrementally more data. And I don't recall exactly how much more data GPT-3 was trained on compared to GPT-2, but it's probably at least like 100 or maybe even 1,000x. I don't have the exact number. You're not going to be able to train a model on 100 more data than what you're already doing.
So that's brilliant. So it's not, it's easier to think of compute as a bottleneck and then arguing that we can remove that bottleneck. But
we can remove the compute bottleneck. I don't think it's a big problem. If you look at the pace at which we've improved the efficiency of deep learning models in the past a few years, I'm not worried about training time bottlenecks or model size bottlenecks. The bottleneck in the case of these generative transformer models is absolutely the training data.
What about the quality of the data? So
the quality of the data is an interesting point. The thing is, if you're going to want to use these models in real products, then you want to feed them data that's as high quality, as factual, I would say as unbiased as possible. But there's not really such a thing as unbiased data in the first place. But you probably don't want to train it on Reddit, for instance. It sounds like a bad plan. So from my personal experience working with large-scale deep learning models, so at some point I was working on a model at Google that's trained on like 350 million labeled images. It's an image classification model. That's a lot of images. That's like probably most publicly available images on the web at the time. And it was a very noisy data set because the labels were not originally annotated by hand, by humans. They were automatically derived from like tags on social media or just keywords in the same page as the image was found and so on. So it was very noisy. And it turned out that you could easily get a better model not just by training. Like if you train on more of the noisy data, you get an incrementally better model, but you very quickly hit diminishing returns. On the other hand, if you train on a smaller data set with higher quality annotations, annotations that are actually made by humans, you get a better model. And it also takes less time to train it.
Yeah, that's fascinating. It's the self-supervised learning. If there's a way to get better doing the automated labeling.
Yeah, so you can enrich or refine your labels in an automated way. That's correct.
Do you have a hope for, I don't know if you're familiar with the idea of a semantic web? Is this a semantic web, just for people who are not familiar, and is the idea of being able to convert the internet or be able to attach like semantic meaning to the words on the internet, the sentences, the paragraphs, to be able to convert information on the internet or some fraction of the internet into something that's interpretable by machines. That was kind of a dream for, I think the semantic web papers in the 90s. It's kind of the dream that, the internet is full of rich, exciting information. Even just looking at Wikipedia, we should be able to use that as data for machines.
Yeah. And so information is not really in a format that's available to machines. So no, I don't think the semantic web will ever work, simply because it would be a lot of work, right, to provide that information in structured form. And there is not really any incentive for anyone to provide that work. So I think the way forward to make the knowledge on the web available to machines is actually something closer to unsupervised deep learning.
Yeah.
So GPT-3 is actually a bigger step in the direction of making the knowledge of the web available to machines than the semantic web was.
Yeah, perhaps. In a human-centric sense, it feels like GPT-3 hasn't learned anything that could be used to reason. But that might be just the early days.
Yeah, I think that's correct. I think the forms of reasoning that you see it perform are basically just reproducing patterns that it has seen in its training data. So of course, if you're trained on the entire web, then you can produce an illusion of reasoning in many different situations, but it will break down if it's presented with a novel situation.
That's the open question between the illusion of reasoning and actual reasoning, yeah.
Yes. The power to adapt to something that is genuinely new. Because the thing is, even imagine you had, you could train on every bit of data ever generated in the history of humanity. It remains, so that model would be capable of anticipating many different possible situations, but it remains that the future is going to be something different. Like, for instance, if you train a GPT-3 model on data from the year 2002, for instance, and then use it today, it's going to be missing many things. It's going to be missing many common sense facts about the world. It's even going to be missing vocabulary and so on.
Yeah, it's interesting that GPT-3 even doesn't have, I think, any information about the coronavirus.
Yes. Which is why, a system that's... You tell that the system is intelligent when it's capable to adapt. So intelligence is going to require some amount of continuous learning. But it's also going to require some amount of improvisation. Like, it's not enough to assume that what you're going to be asked to do is something that you've seen before, or something that is a simple interpolation of things you've seen before.
Yeah.
In fact, that model breaks down for even very tasks that look relatively simple from a distance, like L5 self-driving, for instance. Google had a paper a couple of years back showing that something like 30 million different road situations were actually completely insufficient to train a driving model. It wasn't even L2, right? And that's a lot of data. That's a lot more data than the 20 or 30 hours of driving that a human needs to learn to drive, given the knowledge they've already accumulated.